couple of feet out that way. Okay, let's see if it will burn. It does a spectacular job of burning. And of course, I no longer, now it didn't all burn. Some of it did. And since I know what this stuff is, I'm going to put my finger in it. Normally, you don't go around putting your finger in stuff in the lab. Okay, it started out as that soft silver metal. It is now a grayish-white powder. Okay, we have changed it. It combined with oxygen. When you burn something, you're combining it with oxygen. And so I've got magnesium oxide here. Okay? Now, why do people burn this stuff? The big white light. You want a big white light and not be in a near-death experience. Military flares. Magnesium flares. Your plane goes down or you're lost from the rest and you want to be found. You've got a flare to send up and you're going to be able to see. If you've got a hunk of that, you're going to see that from miles around. Several years ago, a student of mine told me his father was ex-military, and when his father got out of the military, he brought a few of the magnesium flares home. Okay, so when this kid was 10 years old, he and his buddy steal one or two of them. They go out to the backyard and they set one off. Okay. The kid was blind for 3 days. Now, he's just lucky he wasn't blinded forever. Okay, but he was, I don't know what happened to his friend, but he was in big trouble, plus had no vision for 3 days. Okay, so this has a wonderful usage, that if you want to be seen, that's a good way to be seen, is burn some magnesium. That's a property of magnesium. Not only does it burn, but when it burns, it gives off a tremendous amount of light. Old flash bulbs on the old cameras used to have magnesium in them with an oxygen atmosphere, so when you punch the button, you get that one big light. And if you're old enough to remember those, you didn't want to look right at it, or you'd see little white for quite a little bit of time. So, does it burn? Now, glad this was plastic. What's something else? If you have silver jewelry or silverware, tarnish. That's a chemical process, a chemical property. Silver will tarnish when it turns black looking. It's actually reacted with some sulfur from your skin or in the air. And so the old silver polishes used to actually have to take off that layer. And if you lived forever polishing your silver, maybe once or twice a year, the silver would eventually disappear. Now this newer polish actually runs a chemical reaction to reverse that tarnishing process, and it's no longer silver sulfide, but it goes back to being silver. So they've changed the process a little. So will it burn? Will it tarnish? What does iron do? Rust. So stuff like that, those would be chemical properties. Okay, the next section, section 5, physical and chemical changes. And these are very, very, very similar here to the property business. Let's go back and let's do physical first. Physical changes. Changes which we can observe or measure, which does not change the composition of the substance. So we go back to being non-destructive. Okay, now, if I could heat that magnesium, and by the way, magnesium, monatomic, diatomic? Monatomic, okay. I've got some magnesium, and somebody suggested melting it. Now, I'd have to do it real carefully. I couldn't just put it in a Bunsen burner because that's going to set it on the fire. But if I did this very, very gently, I could turn it into liquid. Composition hadn't changed. The phase has changed, but the composition hasn't changed. It's Mg here, it's Mg there. So, here's a wonderful hint. All phase changes are physical changes. You still have the same stuff. Ice melting, it's still H2O. So that's a physical change. Ice will melt. Ice or water will boil. Those are physical changes. So all phase changes are physical. Also, dissolving, if you have some salt, now this is just ordinary table salt, and I'm going to use just passing in a drinking water here. And if you stir it a little bit, it's going to dissolve eventually. Okay, it's sodium chloride, NaCl. I just put it into water, I dissolved it. No, not quite, because it's still kind of cloudy. But let's say I got it all to dissolve. And you've got this, we just hear a public service announcement, all the sodium chloride in the world is gone. And if you have any at home, bring it in and we'll give you $10,000 a grant. And you go, oh my God, I just put it down into water. How would you get it back? Can we get it back? Is it gone forever?
Boil the water.
Boil the water off. And we're going to have the solid sodium chloride. We collect it, we go down, we collect our money, and we're happy. And so a dissolving process is a physical change. Or if we got something to precipitate out of solution, then that's a physical change. It goes in, it comes out. So phase changes and precipitation and dissolving, those are physical changes. Now, chemical changes, as you can probably guess what's coming. Chemical changes, which we can observe or measure, which does change the composition. Okay, we don't destroy matter, we simply change it into something else. Okay, so composition of the substance, so this is destructive. So think, all your physical stuff, non-destructive, all your chemical stuff, destructive, in that you don't have the same stuff anymore. So it doesn't depend upon amount. Now, let's go back. The magnesium, when I burned the magnesium, I was joining it with oxygen. And I should have asked monatomic, diatomic, but I was writing too fast. So we know oxygen in the air is diatomic gas. When this goes together, we get magnesium oxide solid. Now, for you people that have had chemistry before, know that's not balanced, and we don't worry about balancing equations till chapter 3. So, what we're saying is, this is showing us a process, a change. Listen to how you speak. These things are so intertwined. What's a property of magnesium? It will burn. That's a property. Then, this change that we observed is a chemical change. It was a chemical property in that it would burn. Us watching it burn or writing symbolically for that change, that's a chemical change. Okay, so they're very closely related. Okay? All right. Now, on my hair. What's a physical property of my hair? Okay, it's blonde. Maybe real blonde, maybe not so real blonde, but it's blonde. Okay, kind of blonde. Okay, what's a chemical property of my hair? You saw the video.
It'll burn.
It'll burn. I'm not going to find out. Although, actually, in class one day I did. I was illustrating lighting a burner, and I did it wrong. I had a match, and I brought the match to myself. You're supposed to strike away from yourself. I went like that. The head came off. It went in my hair. I set my hair on fire, and I had this wonderful demo of me jumping around, beating the hair, beating on my head to get the flame. I was smothering that small fire, okay, with my hands. So, if you describe it, it doesn't hurt it. That's physical. But if what you do to it destroys it, then that's chemical. And that's the section 5. Now, let's see what section 6 is all about. We're going to revisit this diagram.